Hey guys, welcome back to Thomas's Turf Tips. Today we are talking on our second topic for the smart irrigation timer setup, and that is soil type. In the first episode we did root depth, so today we're doing soil type, and the next time we will be doing precipitation rate and system efficiency. So tune in, subscribe so you don't miss that exciting action. Okay, so for soil type, I'm going to tell you two different methods. One is the jar method. So get you a mason jar, and I have marked it with additional markings here for volume. So we started with the 4, 8, 12, and 16. I added 2, 6, 10, 14. You're going to need that. I've also put in a tablespoon of dry laundry detergent. Okay, so that's what you're going to need. And then you're going to need a soil probe, or just a trowel will be fine too. I have marked my probe to the depth of the roots that I've set in my controller. So I've got it equal to 11 inches. And all I'm going to do is take a sample here. Okay. So that's my sample here. I'm going to take a couple samples throughout the yard just to get a good sampling here. I'm just going to throw that in the jar here. If you see any big rocks or anything like that, take those out. Okay, so that's sample one. Do another sample over here. A little bit harder over here. Okay, so while I'm doing this, I'll explain why soil type is so important. So there's a couple things. Soil type tells your controller how much water the soil can hold. So clay is the highest water retaining soil type there is, and sand is the least, has the least ability to contain water. So that's just telling the system how much it can water at a time. That turns into frequency as well. And conversely, sand can absorb the most water, or have absorbed the highest precipitation rate, while clay has the slowest absorption rate. So what happens, for example, if my soil type is clay and I've got this hill here, it's going to tell the sprinkler system not to water so fast. It's going to take a break, allow the water to soak in, and then turn back on. If it doesn't do that, then you're going to have runoff if you have clay, especially when you have a sloped surface like this. So we're going to take one more sample here and we'll be done. Okay, next thing we're going to do is fill this with water. Leave a little room so you can agitate it. What we're going to do is we're going to shake this vigorously till everything's combined. Be something good for your kids to do. Summer project, science project. Okay, next thing we're going to do, we're going to set our timer for 2 minutes. What falls out first is going to be the sand, and we'll measure the depth of the sand layer after 2 minutes. Okay, so 2 minutes have passed, and so the first layer is going to be sand. And so, as you can see, it's fairly dirty here. The water's not so clear, but you can see it. The layer is around the four ounce mark. I can see it just if I rotate it just a little bit. I can see the sand moving at the bottom. The rest is still suspended, but so I think it's around 4 ounces. So just make a note of what you find as the sand layer, and now we're going to come back in 2 hours and check. That'll be our silt layer. The last layer will be the clay, and once we get all those, we'll get the ratio of sand to silt to clay, and that'll give us soil type. Okay guys, so it's been two hours, and so we're almost at the 12 ounce mark there. So so from sand, which was 4 ounces, to almost 12 ounce mark, so almost 8 ounces of silt. So we're going to give it a 48 hours, and then we will check the total deposits, and so the difference between that silt mark and the top will be clay. All right guys, it's been a week. I checked at 48 hours and realized my experiment had failed. So the good news is we've got a second method that I'm going to tell you about, but just want to tell you what I did wrong here. I put OxyClean in there instead of powdered detergent. OxyClean does not have surfactant, so that's not going to allow all the stuff to fall out of solution. So this is a failed method, but come on in the classroom and I'll show you the easy method. Okay, so welcome to the classroom. So this is a much easier way to determine your soil type. This is a website hosted by the U.S. Department of Agriculture. So I will leave the address to this website in the show notes. But once you navigate here, you're going to be able to navigate to a particular address. I'm actually going to put in the address for Augusta National Golf Club. So let's see what sort of soil type that they have. So I have entered the address and pressed enter, and it's navigated to that. Now you can, if this were your property, you would just circle the perimeter or mark the perimeter with these two areas of interest options here. I'm going to just choose the rectangle and just choose a section here. Okay, and then the next thing we'll do is go to the soil map, and it's going to tell you what the soil type is. So this one looks like there's what they call a complex soil type. So it's got several different layers. The first 0 to 5 inches here is loam. The next is silty clay. So those are the two types that you can choose, and based on your root depth, you'll select the proper soil type for your particular situation. So again, much easier way to do things as compared to the mason jar test. But one caution here is that the system could be fooled here. So if you've had heavy grading on your property and topsoil has not been replaced properly, you may have to revert back to the soil type test using the mason jar. So that's it. Hope you learned something. Thanks for hanging out with me today. Next time we'll talk about determining precipitation rate and system efficiency, so subscribe, and we'll talk to you later.